All right, today we're going to look at that problem. It was number 16 on the worksheet, the secant one. We're gonna look at this problem a little bit differently than we did in class. We're going to apply the skills from chapter 6 for function transformations. So let's first notice here that x is actually first replaced with 2x, which is going to be a horizontal compression of 2, right? So in other words, instead of the periods of secant being 2 pi, the periods will now be pi. Instead of asymptotes happening at every pi halves, asymptotes are going to happen at every pi fourths. After that, right, next step in terms of orders of our shifts and transformations, notice that we were replacing that x and 2x with, in fact, x plus pi halves. All right, so if you distribute the 2 there, right, so now we're looking at the function that looks like secant of 2 times, instead of x, we replace that with x plus, I'll write my pi halves in there, right, x plus pi halves. So if I distribute the 2, we see that that is, in fact, 2x plus pi. So this means first we're doing a horizontal compression, which shifted our period to pi and shifted our asymptotes from being at every pi halves, odd pi halves, to pi fourths. So the space between them is only pi halves. Then we're going to do a horizontal shift of pi halves to the left. So let's sort of look at what this looks like. So I originally started out with, I would have asymptotes at every negative pi halves. Negative pi halves, all my odd pi halves, and the asymptotes are spaced out with a distance of pi between them, right? This distance right here that I highlighted in yellow is pi units, and the period of secant is 2 pi, but there's asymptotes every half of a period. I'm not really interested with where the secant graph turns around, where those minimum and maximum points are. That's what the shift up and the stretch of 5 are going to affect. So if you were doing it with the methods we did in class, you would first look at the cosine of this function, the 2 times x plus pi halves, and then you would figure out where the zeros are from that. The shifting up and stretching is not going to affect the zeros. So from here, this was our original one. We said the first thing we're doing is the horizontal compression. So that means everything is compressed by 2. So instead of a distance of pi between my asymptotes, it's a distance of pi halves, and I'm going to have asymptotes every pi fourths. So they'll be at negative pi fourths. Everything gets squished in. And here at pi fourths, this is my attempt at pi fourths. Let's try that again. So negative pi over 4, and this would be pi over 4, and then I would continue every pi halves would be the spacing, right? So the next one is going to be plus pi halves, which is 2 over 4, so 3 pi over 4. So looking at the pattern, it appears to be all of the odd values of pi fourths. And then again, noticing that, of course, the space in between, right, the space in between my new asymptotes is a distance of pi halves. That's really interesting because we realize that now my next step is to do my horizontal shift, right? The x plus pi halves, that's what I replace next. That's a horizontal shift of pi units to the left. It's going to affect the graph because the period of the graph is pi. However, the asymptotes occur every pi halves units. So if I shift all my asymptotes to the left pi halves, they in fact stay the same. So my answer here for asymptotes is I'd have asymptotes every pi halves units, every odd pi fourths with a distance of pi half space between them. My period of 5 secant 2x plus pi plus 1 would be pi, and I can see that here on the graph that I plotted on the left-hand side of the screen.